Okay, now we're going to switch gears. Bye-bye triangles, hello transversals. And to do this, I'd like to welcome to the stage Miss Wendy Walton. She is a worldwide acclaimed expert on not only the origin of transversals, but the practical applications of parallel insertions in universal dichotomies. There you go.
And I'll look all of those words up later. Thank you. So a transversal line is something that crosses over. And to do that, I'm going to show you a picture because pictures are better than words. So this is labeled for our convenience. This transversal line is something that crosses over another line. So we have this line 1 and line 2, which are being crossed by this transversal. Trans meaning cross. All right. So, and there's no limitation to the number of transversals that can go through other lines right here. So we have our line 1 and line 2. And just going to note here, right here, this down here says that a straight line equals 180 degrees. So this transversal, not only does it create a lot more angles, so when we had our two lines here that are parallel, there are no angles that are formed with our two parallel lines, but once they are cut by the transversal, we have a lot of different angles. We got this angle, we have this angle, all the way across. We have 4, 8, 12, 16. We got 16 angles that are being created. And just to make note down here is that when you have a straight line like this, these two angles are going to equal 180 degrees. But there are more than one straight line being shown. Let me switch to black. So we also have a straight line right here. So just be aware of that as we go through, that there are, whenever you have a straight line, even if it's turned to its side, it's still a straight line. Like if my arm's straight here, it's still a straight line, it's just from a different perspective.
So, if all I gave you was a transversal and one angle, could you use your knowledge to figure out every other angle in the entire thing? And the answer is, yeah, you could. Check it out. So here's our transversal. And I tell you that up here we've got a 30-degree angle. Now you know, because you're smart, that every straight line has 180 degrees. So if I'm walking through the shopping center of a straight line, I spend $30 right here, okay, in this part of the angle. And I started with $180, so how much do I have left to spend on this angle? And the answer is going to be 150, because those are the two numbers that will add up to 180. And if that's 150, then I could start walking down this straight line. And if I've used $150 out of my 180, that happens in every straight line, then how much do I have left for this little part right here? And the answer is 30. Oh, this is interesting. And then if I was walking this way now, down this straight line, then I spent 30, how much do I have left? See, there's a pattern happening. And here's the pattern, and here's the good news about transversals. When you're working on a transversal and you're looking for angles, there are only going to be two different numbers in the entire transversal, and they're just going to pop up over and over and over again. All you got to do is put them in the right place. Interestingly enough, by the way, remember how there's like 180 degrees in a triangle and 180 in a straight line? Do you remember how many degrees there are in a circle? You've heard it before, you've learned it, it's not stuck in your head, but maybe you remember it's 360. Look at that. We made a circle, and all those numbers add up to 360. Anyhow, if that angle's 30 and that angle's 30, well then look down here. That's also 30, and that's also 30, and then these two right here, see that? Same angle right there. So that's also 150, and that's also 150. And you can fill out everything on the entire transversal just by starting with one number, because there's a lot of repetition. There's a pattern that builds. Yes, ma'am. Yeah.
Question. So this pattern always happens when a transversal cuts through any lines?
Yes, as long as the two lines are parallel.
Okay.
Yeah.
Sorry, parallel lines.
The lines have to be parallel. Yes. So that's really important. That's a good question. If they're not parallel, it ain't a transversal, at least not in this regard. Here's something that I'm going to ask you to do that will really help you as you navigate some of the questions that will come from this topic. Whenever you get a transversal, you're going to need to label it, okay? AA, BB, and then AA, BB. And here's what that means. The A angles are exactly the same, okay? Because this one is like, it was the 30 degrees, remember that? And then this one was 150, and then this one was the 30, and this one was 150. And they're always going to be across from each other. This is actually called vertical angles, and you'll run into that later. But right now, if you just kind of recognize these are the same, and these are the same, say, call them A, A, B, B, and then go down here and follow the same pattern, A, A, and B, B. Because if you will start your transversals like that, okay, then it's going to provide a lot of benefit for you when you get into some of the more challenging questions about this topic.
So when you're watching this video, there is an activity that's going to be posted. It's Desmos, maybe you've used it in the past. It's an activity that will take you through a practice that will apply all of the vocabulary and things that we've talked about up to this point. And you should be able to work through this activity. So this would be a great time to pause and go through this activity that is posted in Google Classroom the same day as this video that you're watching. And calling back Mr. Campbell, who is going to talk about what we do if we start seeing variables, because I thought those were only for equations.
See, it's about to get mushy up in here. When I gave you a number, then you remember you could just like figure out how to make the 180 and figure out the other numbers. We just like went through the whole thing, put all the numbers there. Problem, the numbers are gone. Now you're lost in variable land. What are you going to do? You're going to label it AA, BB, AA, BB. And then you're going to look at it and you're going to say, what's all that mess up there? And what's all that mess down here? And what do I do with it? And then you're going to realize something. This angle, which is angle B, is the same as this angle, which is angle B. So whatever angle B is, it's 2x plus 3. And whatever angle B down here is, it's 4x minus 5. I know it looks like those would have to be the same expression. Like since that's 2x plus 3, shouldn't that be 2x plus 3? The answer is kind of, but just bear with me for a second. Trust in the truth that this is the same as that. And in math, how do we show something is the same? Equal sign. Behold. 2x plus 3 equals 4x minus 5. Huh. That looks like an equation, Miss Walton. Do we know how to solve equations?
Yeah, we do.
We sure do. We've got variables on both sides, so I'm going to find the variable with the least coefficient and do the inverse. Boom, boom, boom. I call them killing the chickens. And then I'm going to rewrite it based on that new modified equation, 2x minus 5. And now I've got some rats hanging out here in my barn on the side by the chickens. I want to get rid of the rats. The best way to get rid of negative 5 rats is to add 5, and boom, 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 and they kind of disappear. But I've got to do the same thing over here. I've got this line between the two sides of my equation all the way. Now I've got 8 equals 2x. G at the very end, I think we all know that it's time to divide. So I'm going to divide by 2, running out of space, x equals 4. Now here's what you just did. You had no idea what that angle was, and you had no idea what that angle was. All you knew was that this had to be the same as that. And then you solved. You said x equals 4. Well, now you can plug x back in to the expression, and you go, well, 2 times x, 2 times 4. 2 times 4 is 8, plus 3 would be 11. Now, don't get freaked out, because that's not an 11-degree angle. That's way too big. But we're just pretending that it is, because the math would call it an 11-degree angle. And then over here, 4 times x, 4 times 4 is 16. 16 minus 5 is also 11. Look at that. 2 11-degree angles, and then we could fill in everything else. So if you run into these guys, variables in the transversal, then label everything A, B, A, B, A, B, A, B, A, B, and you will find a way to get it worked out. Ms. Walton, show them how to do it. They see transversal. They see variables, and they're like, what do? What are they going to do?
I'm going to say, oh yeah, if this is A, that's what Mr. Campbell said, then this is also A. But this can't be A because it looks way different, right? So this has to be a B, which makes this one a B. And if this is an A, then this also is an A, which makes this an A. Oh yeah, and this is a B, and this is a B. So what we know is that B equals B, right? And A equals A. So in that last slide with what Mr. Campbell did, he took, if we know that B, we now have some variable action going on. So we know that our 2x plus 3 has to equal 4x minus 5.
And then you solve it.
And then you solve just like Mr. Campbell did.
So AB.
Oh, you want me to go?
No, go forward. Because that's the next one. And then, oh yeah, you got to tell them about what to do in that situation.
Oh, okay. So it was pretty easy because it's nice to know if B equals B, and we set the two expressions equally to each other. But now we have A equals 2x plus 1, and B equals 4x plus 5. Well, A doesn't equal B because A equals A and B equals B. So we need to solve for X because they're asking us to find the angle, but X doesn't help us because it is just an unknown number. But what we do know is that a straight line is 180 degrees. And if we notice, every AB combination falls on a straight line. We have AB there, or we have AB here. We have an AB here, and an AB here. And just like we know that A plus B is the same thing as B plus A. So with this one, we can take A plus B, and this has to equal 180. So we know a little bit more information. So what we can do is take our A, 2x plus 1, plus our B, which is 4x plus 5, and we can set this equal to 180. So what we're going to have to do is solve this equation by first combining like terms. So I'm going to circle and box like we have done this year. Draw our line. So on the left side, 2x plus 4x is 6x. 1 plus 5 is 6 equals 180. Then we're still trying to get our x by itself, so we're going to have to subtract 6. This goes away, and we're left with 6x on the left equals 180 minus 6, which is 174. And the last step is to divide both sides by 6, and we're left with x equals 174 divided by 6, which is, drum roll, 174.
29.
29, thanks Mr. Campbell. 29. So the problem is this is not a degree measurement. What this is a variable that we can then use to substitute back in. So if I take my x and I take it and I can substitute it in where we have our numbers missing. So then we can find 2a equals 2 times 29 plus 1, and b equals 4 times 29 plus 5, and then simplify.
Yep. Solve that. You got your answers. And I think we are pretty much at the end. All I would tell you here is what she told you on the last one. When you see this, immediately A, and B everything, so you can see them in their proper relationship all the way through. You might even have like a 2x plus 1 up here and something else down here. As long as you've AB'd the whole thing, you'll be fine. So see this right here? Every time. If the transversal is very slanted like that, it's easy to see the distinction between the angles. But right here, it's a little bit harder to see the distinction. This might be 91 degrees and this might be 89 degrees. And you're going to need to AABB everything, because then if I ask you, hey, this is 2x plus 14 and this one down here is 2x plus 13, okay? Are you supposed to set those equal to each other? Or are you supposed to set them equal to 180? Well, it depends on where they're at in the AB pattern. They're in different spots, so they need to add up to 180. If they're in the same spot, like if that was over there, then you could set them equal, okay? Gotta AB the stuff. And yes. Okay, so here's a sample question. You probably can't read all the text, so I'm just gonna paint the story for you. The lines are parallel, there's a transversal. Based on the diagrams, what's true? Now here's the trick. This is, I love this. Okay, zoom in on this, zoom in on this. This is a star question. And when you get a star question like this, they're actually throwing a lot of extra information at you. All they want you to do is solve for x. And this, and this, and this don't matter, because that's not where x is. All that matters is this. They want to know what the angle measurement there is. So here's what you've got to do. A, B, A, B, A, B, right? A, B, B, A, B, B. Okay? Is this an A angle or a B angle? It's a B angle. Do we have a number for a B angle? Sure do. If you can't read it, it's 79. So if that's 79, guess what that has to be? 79. What do you do? Find an answer, sorry trash can, that says 79. Don't even worry about all these other words. They don't matter. The value is 79, so it's 79. You're good, right? Don't get overloaded by too much information. That's what the internet's for. Okay, Ms. Walton, last problem, and we're done.
All right, so we're given that the lines are parallel and that we have an intersecting transversal. So we know parallel lines with a transversal create our AB patterns. So on each of these, I would go ahead and write in that AB pattern. AB, AB, and AB. I'm not even sure if I need to be doing all of this.
You don't. You just need to. You only need to work it on the one where
the one where the variable's missing. Thank you. So if this is AB, this is AB. So where this falls, A, B, B, we see that the X and the X is on a B and the 75 is on a B. So we know that X has to be 75 because B equals B. And then we have our value of X should be 75.
Boom. That's the teaching. Have fun with the assignment. Bye.